Here's another video about outliers, leverage, residuals, and influential points for linear regression. It's going to have a lot of overlap with the other outlier video I did, but I want to do it in a little bit differently and focus on things maybe in a little bit of a different way. So these are the four terms I want to discuss. The first one is simply an outlier for a regression from a two-variable problem. That just means if we've got a group, here is a simple group of 5 points. This is based loosely on a problem from Bach, Feldman, and DeVoe. We've got this group of 5 points, and here's another data point. If it's away from the data in any direction, significantly away from the data in any direction, then it's going to be an outlier. Out here, out here, out here. Not here, not here, not here, not here, not here, but out here, or here, or here. But those different outlying positions have a very different effect, as you can see on the best fit line. We want to explain that. The first concept to explain that is leverage. A point has high leverage if its x value is very far away from the mean of the x values of the whole group. Okay, so the mean of this group is going to be right here at 2. Even if I include this guy, the mean isn't going to get pulled up super much because there's 5 of this and only 1 of this. The mean's maybe somewhere around here, and it's way above that mean. Okay, so that gives it high leverage. What does that do? Well, what we can see is that the best fit line tends to track this point very closely. Even if I go down here, it's still close to it. And notice with these 5 points, these 5 points are completely symmetrical. If this point didn't exist, the best fit line would be horizontal. When you have no preference for an uphill direction or a downhill direction, the default is 0. The correlation is going to be 0, and so the slope is going to be 0. This is dramatically different from 0 slope, which would be indicated by these 5 points. And so this point is having an outsized effect. Only one point is dragging very close. And notice the best fit line ends up being very close to this point and pretty far away from this point and pretty far away from this point. So why is that? Well, let's look at let's delete the least squares line for a second and add a movable line. So this is not the actual best fit line, but I'm going to try and freehand it and see what happens. And it's going to give me, oops, what I'm going to do is I'm going to show the squares. Okay, what this gives me is a visual impression, as I've done in other videos, of how bad a fit it is. Okay, so the sum of squares is 8 here. That's pretty, maybe about as good as I can get. Let's see. Okay, yeah, somewhere around 8. Okay, so notice what's happening. I've got some pretty big squares here because I've got a bad residual here from that point and that data point. Okay, so I could try to fix those, but as soon as I start changing the slope of this line, notice what happens. These guys get a little better perhaps, but this guy starts to inflate really strongly because it's exactly the lever principle. If the slope of this line changes a bit, then the heights in this area don't change that much, so it doesn't have that much of a good effect, if it can have any good effect, on the residuals here and the sum of the squares here, but it's blowing this guy way big. And notice the sum of squares now is almost 16. Okay, if I try to lever it even further down, I can lever it in such a way that I can make these guys significantly smaller, but not tremendously smaller. The best fit for these 5 guys over here is horizontal or close to it. But as I do that, I change these guys for maybe a little for the better, but this guy's getting dramatically inflated. That's because when I have a large difference in x values, every difference in slope that I make pivoting around here is going to increase this by a lot. It's exactly the principle of the lever, that turning a lever by a small amount, if it's got a large lever arm, actually moves the end of that lever by quite a bit. So what that means is the best fit in terms of these squares ends up being very close to this guy. And that's not necessarily what you want. You might not have, let's go ahead and take out that movable line, and let's put in the real thing again. There it is. You might not be that happy with this guy, because since it's an outlier, it might be suspect. And it might not even belong in the data at all, and yet it's dramatically influencing what I think about the best fit for that data. These guys are not showing a trend. This is the only thing that's showing a trend. Should it really convince us that there really is a trend? That's the question. So that's how high leverage works, or one explanation of how high leverage works. When that x value is really far away, it's going to tend to drag the line with it. Okay, let's think about high residuals. Okay, so let's go back here. Oh, and I want to put the residual plot in now. Okay, so now this is the residual plot. So that all that does is it takes, for each of these data points, it says how far is it away from the best fit line. So this is this far away, and so that's how negative this is. This guy is a little bit above, and so the residual is positive. This guy's strongly above, so it's got a pretty big residual. This guy's pretty strongly below, so it's got a big negative residual. This guy's pretty much on the money, so it's very close. Okay, so notice if you have some sort of qualms about your regression, you often do a residual plot and then see, are they big? Are they really big residuals? If they are, that's evidence that it's not a very good linear fit. Well, these are big. This one isn't showing up as big. Okay, so that doesn't give you cause to be worried about this outlier. But because it has high leverage, there's a reason why it doesn't have very big residual. It's dragging the line with it. So if you think this point is really, really significant in your data, then maybe that's okay. Maybe there is actually a real correlation here, and it just happened to be that these guys weren't showing it yet. But if you have any suspicion about this point, the residual plot is not going to show that, but looking at this picture and noting that it has high leverage is going to say, hey, wait a minute, no matter what I do, the line has to follow this point because of the high leverage. That's kind of suspicious. Okay, and I'm not going to see it from the residual plot. Now, what is a point that is going to have high residual? Well, let's look at something where the y value is very different from the x values, and but the x value isn't very different from the mean. So this is actually a point with very low leverage. And so notice, when I move this around, it is not attracting that point, the best fit line, close to me. And in fact, the residual here is so low, it isn't even showing up on that residual plot. See, there it is. Even on this scale for the residual plot, it's way, way down. Okay, it's got a really huge residual. It's very far from the line. Okay, it's not even able to show it on that scale. So here's what's happening with this guy. Because it's got such a small x value, there's basically no way I could tilt this line to make this residual small. If I tilt this line around an axis in here, it's going to be, let me try that. Let's take away the least squares line again. Let's add a movable line. Okay. I know the line should be generally going through this bunch of points. Okay. And so I'm going to want to pivot it around the middle of those points. Okay, so if I pivot it down, is this residual changing very much? Nope. Okay, if I pivot it up, as long as it's going sort of right through these points, it's not changing very much. The only way I could fix it would be to put it way down here. Is that a good idea? I don't think so. Let's show the squares to see. No, that's horrible. I've got a bunch of huge residuals. I got 5 big residuals from these points and only 1 small here. So that says, no, I really should be up here. Okay. And the truth is, I can't get this guy to be small, because there's no way to do that without dragging the line actually close to it here, and that makes all 5 of these points go crazy. So let's go back to the real thing. And that's why this guy has some effect on it, but it's never an effect that drags it really close to it, and never an effect that has a small residual. Okay? And part of the punchline here is that should I be able to confidently predict the y value based on the x value in this situation? I've got 2 x values that are very close to each other, but with dramatically different y values. That's telling me the y is not predictable given the x. So this point is definitely going to suggest that I shouldn't even be trying to do a linear model. I can't get a good fit. I'm going to get, notice how small the r squared is. It's a tiny, tiny number. This is horrible for a linear model. So this is definitely going to have a high residual. In the medium case, where it has some leverage, okay, this could have, it still has a pretty decently high residual, because it's not yet over in this case where they have the super high leverage. Okay, so anything that's really far away from the line vertically is something with high residual. Influential, that's something that anything where the best fit line is very different if the point is deleted. High leverage points are almost always influential. This guy has dragged the point down. If I then go ahead and delete that point, let me do that. If I just delete this guy, whoa, the best fit line is dramatically different. Okay, if I put it back in, let's say, what was it, like 8 and -2, then again, it's very different. Well, what about something that was the previous case where it was high residual but low leverage? Let's just put this in at like x equals 2 and minus 2. Okay, that isn't actually that different. As I move it around, it has some effect. What if I delete it entirely? It's not a dramatic effect. And so that actually wasn't a super influential point. So influential is a little hard to read off just from the scatter plot. You actually sometimes have to really do the analysis to see it. But certainly anything with high leverage is likely to be influential. And that's the main thing I wanted to get across, is that that's an easy reason that you can see from the scatter plot for something to be influential. Okay, I think that's all I wanted to say.